Hi everyone, welcome to your favorite learning channel. We will continue with the topic that we have been doing on algebra, the fundamentals of algebra. We've covered fundamentals, the substitution process, the addition, subtraction, multiplication, and division. We've also done the algebraic fraction and expansion. We will now do binomial products, special binomial products, and then we will get into some problem solving related to the topic. If you have any questions related to what we have done or what we want or you want us to do, or if you have any clarifications for this, please provide comments and we will try and answer them. Okay, so today we are doing binomial products. So in mathematics, terms that are added or subtracted like this are known as binomials. Right? Now, how do you do product of two binomials? The process is that, remember, this is one quantity and this is one quantity. And because we do not know the exact sum of a plus b, similarly c plus d, we can't take this as one quantity and multiply it with the other. So what we will have to do is we'll have to multiply them individually. And how do you do that? The process is that each of these quantities or each of the components of these quantities will have to be multiplied with this. So what we do is we take the first factor, multiply with this entire thing, c plus d. A has been multiplied by c plus d. Similarly, plus b, it has been multiplied with c plus d. So what we have essentially done is we have multiplied the first quantity with the entire first part of the first quantity with the entire component, and then we have multiplied the second part of the first quantity with the entire thing. So essentially we have done this times this and then plus this times this. So we have separately multiplied. Now we'll expand based on whatever we learned in the previous topic. AC plus AD plus BC plus BD. If there are similar terms, we'll simplify, otherwise we'll leave it like that. Okay, so that's how it is. So basically what you do is you multiply the first term in the first bracket by the entire second bracket. Similarly, you take the second term and then you multiply it with the entire second bracket. Let's take some examples. This is how we do it, right? Let's take some examples. So we have 3x plus 7 and 2x minus 3. Same process, I take 3x and multiply it with 2x minus 3. I take 7, multiply it with 2x minus 3. 3x gets multiplied by 2x minus 3, 7 gets multiplied by 2x minus 3. 3x into 2x is 6x squared. 3x minus 3 becomes 9x. Okay, plus 7 times 2x is plus 14x. And then plus 7 minus 3 is minus 21. Can we simplify further? Yes, we can. 6x squared minus 9 plus 14 is plus 5x minus 21. That is your answer. Okay, this is how you do multiplication of two binomial products. What would happen if I give you these two terms to multiply? Terms that are similar to each other. X plus y times x plus y. We will use the same process. X times x plus y. So this is the x, this one, and this x plus y is this one. then y. This is y times x plus y. So we get x squared plus xy plus xy plus y squared. Any simplification? Yes. X squared plus 2xy plus y squared. Okay. Now this is a special binomial product that we will learn about a bit later, but the process remains the same. Right? Let's say we have something like 2x plus 3 and minus 3x plus 7. Process remains the same. 2x times minus 3x plus 7 plus 3 times minus 3x plus 7. That is equal to minus 6x squared plus 14x minus 9x plus 21. Minus 6x squared plus 5x plus 21. Okay. Next example that we want to take is of this nature: 2x minus y and 2x plus y. We'll use the same process, but we'll learn a new concept. 2x gets multiplied with 2x plus y, minus y gets multiplied with 2x plus y. So 2x times 2x. So we expand this, we get 4x squared like everything else, and then plus 2xy. This gets expanded, minus 2xy minus y squared. These two gets cancelled out, so you will be left with 4x squared minus y squared. Now, what we have seen in some of these examples is what we call the special binomial products. What does it mean? So, these are binomial expressions that are very, very useful, and we should commit this to memory. A plus b whole squared is equal to a squared plus 2ab plus b squared for any a and b in universe. A plus b whole squared. So when you do a plus b whole squared, which means you are multiplying a plus b times a plus b, something like this. You get the square of the first quantity, you get the square of the second quantity, and you get twice the product of a and b. Similarly, if you do a minus b whole squared, you get a squared minus 2ab plus b squared. These two quantities are the same. The middle quantity has a different signage because this has a different signage. Okay, and a third and a very, very interesting one is when you multiply a plus b times a minus b, what you get is a squared minus b squared. So please multiply all of these three using the equation and processes we have discussed earlier, like these and this, but commit this to memory. So you can verify it using these processes, but commit these things to memory. These are very, very important formulas and are used extensively for very many purposes. We must remember these things because it can shortcut a lot of our work that we are going to likely to do. Okay, so let's take some example. Some further examples to simplify things. So someone tells me, how can you do 2 3x minus 5 whole square? Calculate this. Right. So what will I do? 2 is a coefficient. I'll keep it this side. I can 3x minus 5 is 3x minus 5 and 3x minus 5. Right? I'll continue to use the same process that I have done in this. I will do 3x times 3x minus 5 minus 5 times 3x minus 5. And then this 2 remains outside. So this is 3x times 3x. We all know it. 9x squared. 3x times minus 5 is minus 15x. Minus 15x again because of this, and then plus 25. Can you simplify this further? Yes, we can. 9x squared minus 30x plus 25. And then you multiply this by 2. 18x squared minus 60x plus 50 is your answer. Okay. We could have also done this using this formula. So let's do that. So we keep 2 outside, and remember a, this is a and this is b. A minus b whole squared. This is a squared. So the square of 3x minus 2 times 3x times 5. You don't have to take minus 5 because the signage takes care of that. Plus b squared is minus 5's square. So 2 times 9x squared minus 30x plus 25, and this is equal to 18x squared minus 60x plus 50. Gives you the same answer, just a couple steps less. That is why these formulas are very important, because whenever we have to do a square of a binomial, or we have to do a sum of a product of the difference of two binomials, this is very, very useful, and we are going to use this in a number of our calculations. So whenever we have these special products, we call them special binomial products. A plus b whole squared, a minus b whole squared, a plus b times a minus b. You can use this simple formulas that will always work for all products. Let's take some more example, and then we will learn how to do this simply. 5x plus 2 squared minus 3 plus x and times 3 minus x. This is an interesting question because we will have to use multiple formulas to solve this. Okay, so we will use the formulas. So this is a plus b whole squared. Okay, so we will use the special formula. Remember what is the formula? A squared. So a is 5x squared plus 2 times a times b plus b squared. Right? This is what we've done. Now, if you take this minus, we can use this as this formula. A plus b times a minus b, and the answer is a square minus b square. This is a plus b and a minus b. A square minus b square is 3 square minus x squared. Simplifying this further, 25x square plus 20x plus 4 minus 9 minus x square. 25x square plus 20x plus 4 minus 9 plus x squared. 26x squared plus 20x minus 5. That is your answer for this. Right? So you have to be careful with some of these signages or things like this. But otherwise, this can simply use the formulas that we've learned earlier. Okay, we'll take one more example that demonstrate the complexity that you may be able to get in some of the exam problems. So let's take a question which says we need to find out the value of this. Okay. So we'll try solving this. This is outside the bracket, we'll keep it outside the bracket. This is a minus b whole squared. So a squared minus 2ab plus b squared. Four x squared minus 16x plus 16. Right? Now we can do a few things. We can multiply x inside, or we can take 4 common, because 4 is common in all of them. Half x times 4, this becomes x square minus 4x plus 4. This 2 gets cancelled, so you're left with 2x. X square minus 4x plus 4. This gives you 2x cubed minus 8x squared plus 8x. That is the answer. You can leave it here, or you can leave it here. We'll do one more question. We wanted to do simple questions so that we could explain the concept. Now, subsequently, we can do a bit more complex questions that you may face in your exams. Okay, so how do you solve something like this? Remember, fraction addition, we will take x plus 1 and x minus 1. Because they have nothing in common, you just multiply them and that becomes their LCM. X plus 1 gets cancelled, you multiply this quantity with x minus 1. Similarly, you multiply this quantity with x plus 1. And this becomes squared. So this is x minus 1 square, this is x plus 1 square. 2 common, x minus 1 squared is x square minus 2x plus 1. And then this is 2 times x square plus 2x plus 1. All of these have been added. Now this is a formula, right? A plus b times a minus b is a square minus b square. 1 square is 1. So we have to simplify the numerator. So we get 2x squared, we multiply and expand, minus 4x plus 2 plus 2x squared plus 4x plus 2. Right? 4x squared. 2x squared plus 2x squared is 4x squared. Minus 4x plus 4x cancels each other out. You're left with this plus 4. So this will be, take 4 common, x squared plus 1 by x squared minus 1. That will be your answer. So you can write it like this, 4x squared plus 1 by x squared minus 1. Okay. We'll do one more question. And let's multiply with 2. 3x minus 2y, 3x plus 2y. Things like these are very simple. When you have two quantities which has a sum and a difference, and they want to be multiplied. This is a minus b times a plus b. It doesn't matter whether it is a plus b times a minus b. The formula works correctly for both sides because they are just being multiplied. So whether you multiply 3 times 5 or you multiply 5 times 3, it's the same, right? Similarly, whether you do a plus b times a minus b or a minus b times a plus b, it's the same. So the answer is 3x squared minus 2y squared is equal to 9x squared minus 4y squared. That's your answer. We'll take one more final question. Minus of 3x minus 2 squared. So this is an interesting problem. You have minus, nothing here. Remember I said if you don't have anything, assume it is minus 1. And then we will take the brackets. This is a formula, a minus b whole square. So a square minus 2 into 3x times 2 plus 2 squared. So minus 1, 9x squared minus 12x plus 4. Right? Now you can open the bracket. So you're left with minus 9x squared plus 12x minus 4. That's your answer. Right? So don't get confused if you have a minus outside. You can use this as minus 1 and multiply the result. Okay, thanks for watching this. This is where we complete the first chapter on algebra, where we've learned these topics. We've learned from the basics, and we've also solved some questions. If you like this, or if you have any doubts on these topics, feel free to comment and we will try and answer your questions. Like, share and subscribe this video, because then this will reach more people who can find it useful. Thanks for watching. These are the topics we've covered. Next topic we will cover will be on indices. Thank you.